A single load of firewood burned once over a 2-hour period heats an Amish farmhouse for 60 to 72 hours in typical winter conditions. That statement sounds impossible to most homeowners familiar with conventional wood stoves that require loading every 4 to 8 hours. But Amish masonry heaters accomplish exactly this performance reliably across entire winter seasons. The secret involves massive thermal storage combined with extremely efficient combustion, producing a heating appliance that captures essentially all of the fuel's energy content and releases it gradually across days rather than hours. Typical Amish families using these heaters burn 2 to 4 cords of firewood annually to heat substantial farmhouses through brutal Pennsylvania or Ohio winters, compared to 6 to 12 cords that conventional wood stoves would require for equivalent heating service. The total winter fuel cost might reach $300 to $600 for firewood purchases, or essentially nothing for families harvesting their own wood from farm woodlots. A household converting from conventional heating to masonry heater operation typically reduces winter heating costs by 60 to 85%, while gaining dramatic improvements in comfort and reductions in maintenance demands. The heaters have been built and operated continuously across Amish communities for over 150 years, with construction knowledge passed through multi-generational apprenticeships and practical experience. The design principles are documented, the materials are widely available, and the performance exceeds nearly every alternative heating approach. Yet outside specific traditional communities, masonry heater installations remain rare despite their extraordinary advantages over conventional heating alternatives. The Amish masonry heater differs fundamentally from conventional wood stoves or fireplaces through its integration of combustion and thermal storage into a single massive structure. Rather than burning fuel for immediate heat release, the heater burns fuel rapidly and intensely in a combustion chamber, then routes the hot combustion gases through an elaborate system of channels in massive masonry. The masonry mass, typically 4,000 to 8,000 pounds of stone, brick, or purpose-made refractory blocks, absorbs heat from the combustion gases as they travel through internal channels. Once combustion completes, the stored heat radiates gradually from the masonry surfaces into surrounding rooms across the following 60 to 72 hours before the next firing. The combination of rapid, intense combustion with extended thermal storage produces performance characteristics that no simpler heating approach can match. The combustion chamber design in Amish masonry heaters optimizes for complete fuel combustion during the short, intense firing period. Typical combustion chambers accommodate 40 to 80 pounds of firewood in a single loading, burned across 90 to 150 minutes at temperatures reaching 1,800 to 2,200 degrees Fahrenheit. The extreme temperatures produce essentially complete combustion of both primary fuel and combustion gases, extracting nearly all available energy from the fuel while producing minimal emissions. Properly operated masonry heaters produce particulate emissions comparable to natural gas heating, dramatically better than conventional wood stoves despite using the same wood fuel. The clean combustion profile has earned masonry heaters exemption from various wood-burning restrictions in jurisdictions that otherwise limit solid fuel heating. The internal channel system in typical Amish heaters routes combustion gases through 25 to 45 feet of serpentine pathways within the masonry structure. The extended contact path between hot gases and cool masonry produces dramatic thermal transfer, cooling combustion gases from peak temperatures to temperatures below 300 degrees by the time they exit through the chimney. The temperature drop across the heater represents approximately 85 to 92% thermal efficiency, meaning nearly all the fuel's energy transfers to the masonry for subsequent radiation to surrounding rooms. The remaining energy exits through the chimney along with combustion byproducts, representing unavoidable losses in any combustion heating system. Jonas Yoder builds traditional Amish masonry heaters as part of a construction business serving plain communities across Pennsylvania, Ohio, and Indiana. He has constructed approximately 340 heaters during his 22 years of practice, continuing the multi-generational family tradition of specialized masonry work. His heaters follow specific design patterns refined across generations of Amish building experience, with slight variations to accommodate specific homes and family needs. Typical installation requires 4 to 6 weeks of work producing a heater that family members can reasonably expect to operate continuously for 200 years or longer. His documented performance data across homes using his heaters shows consistent winter fuel consumption of 2.5 to 3.5 cords annually for homes ranging from 2,000 to 3,500 square feet. The materials used in traditional Amish masonry heater construction include specific combinations selected for their combined thermal and structural properties. Firebrick lines the combustion chamber and internal channels where direct flame contact occurs, rated for temperatures exceeding 2,500 degrees and resistant to thermal stress damage across repeated heating cycles. Denser masonry materials including fireclay brick, cordierite blocks, or purpose-designed masonry heater components form the outer structures that store and radiate heat. Exterior finishes range from utilitarian painted finishes to elaborate decorative treatments using soapstone, tile, or ornamental brickwork. The material costs for typical heater construction run $2,500 to $5,500, depending on specific materials selected and elaborate decorative work incorporated. The operational practices that maximize masonry heater performance involve specific techniques refined through generations of Amish practice. Starting fires efficiently requires proper kindling arrangement and rapid ignition of the fuel load to reach operating temperatures quickly. Managing the combustion air supply during the active firing period maintains optimal combustion conditions without wasting fuel through incomplete combustion or excessive air infiltration. Closing the air supply appropriately after combustion captures maximum thermal storage in the masonry while preventing heat loss up the chimney. These operational skills develop through experience, with experienced users achieving substantially better performance than novice operators. Martha Stoltzfus has operated her family's masonry heater for 31 years and has documented detailed records of winter heating performance across multiple generations of her Pennsylvania farmhouse occupation. Her records show consistent patterns of winter wood consumption averaging 2.8 cords annually for a 2,400 square foot farmhouse, with variations related to specific winter weather severity. Interior temperatures throughout her home remain consistently between 64 and 72 degrees during winter months, with daily heater firings during cold weather and every other day firings during milder conditions. Her heating fuel costs, primarily representing her own labor in wood preparation rather than purchased fuel, amount to perhaps $150 to $250 annually in equivalent economic value. The architectural integration of masonry heaters into home design substantially affects both aesthetic and functional results. Traditional placement positions the heater centrally in the home where its radiant heat distribution reaches multiple rooms simultaneously. Some designs use heaters as room dividers, separating living spaces while providing heating to both sides. Other designs incorporate heaters into kitchen spaces where cooking functions combine with heating. The mass and permanence of masonry heaters means they become substantial architectural features of their homes, with design integration affecting daily experience across decades of use. David Esch operates a specialty heating consultation business, serving both Amish and non-Amish clients interested in masonry heater installations. His work spans the Mid-Atlantic and Midwest regions, with installations in homes ranging from traditional farmhouses to contemporary custom homes. His documented client base includes 87 completed masonry heater projects, representing collaborations with various masonry contractors who actually perform construction work. His design consultation emphasizes matching heater capacity to home heating requirements, selecting appropriate placement for optimal heat distribution, and integrating heaters into architectural designs for both function and aesthetic success. His fees typically run $1,500 to $4,000 for comprehensive design consultation on complete heater installations. The cooking applications integrate naturally with masonry heater functions in appropriate designs. Many traditional Amish heaters include cooktop surfaces heated by combustion gases, oven compartments heated by the same thermal energy, or warming compartments that maintain food at appropriate serving temperatures. These cooking functions utilize heat that would otherwise be released into general thermal storage, effectively providing cooking services without requiring separate fuel consumption. Families with integrated cook heater installations often prepare substantial winter meals using the heater alone, further reducing total household fuel consumption while providing cooking convenience that electric or gas alternatives cannot match. The durability of properly constructed masonry heaters far exceeds that of conventional heating equipment. Original heaters built in Amish communities during the 1870s and 1880s continue operating today with minimal repairs, representing service lives approaching 150 years. The core structural elements including firebrick combustion chambers, thermal mass blocks, and structural supports show remarkably little degradation even after centuries of thermal cycling. Occasional refractory replacement in combustion chambers, perhaps every 40 to 80 years of continuous use, represents the most substantial maintenance intervention typically needed. These extraordinary service lives transform masonry heaters from heating appliances into permanent architectural features of the homes they serve. Sarah Byler documents historical masonry heater performance through her work as an Amish community historian and preservation advocate. Her research covers approximately 280 heaters built in various Amish communities across the past 150 years, with ongoing documentation of continued operation, maintenance requirements, and performance characteristics. Her findings show that properly constructed masonry heaters from the 1890s and earlier continue delivering reliable heating service today, with total maintenance costs across their extended service lives amounting to perhaps $5,000 to $15,000 per heater across 125 years of operation, compared to the 8 to 12 complete heating system replacements that conventional equipment would require across equivalent timeframes. The masonry heater economic advantages compound dramatically across multi-generational timeframes. The regional adaptations of masonry heater design have evolved across Amish communities in different geographic locations. Pennsylvania Amish communities have refined specific designs optimized for the regional climate characteristics and locally available materials. Ohio Amish designs emphasize slightly different features appropriate for their regional conditions. Indiana and other Midwest Amish communities have developed additional variations. The accumulated regional expertise means that local Amish builders typically can recommend designs specifically appropriate for local conditions, drawing on generations of practical experience with what actually works reliably in specific climate and geographic contexts. Now for the obstacles and considerations that affect broader masonry heater adoption in non-Amish contexts. First, the construction cost for complete masonry heater installations substantially exceeds typical heating equipment costs. Total installation costs typically run $8,000 to $22,000 depending on size, materials, and complexity, compared to $4,000 to $12,000 for premium conventional heating equipment. The initial investment premium can deter homeowners despite the favorable long-term economics that heater operation produces. Second, the specialized construction expertise required for proper heater construction is concentrated in specific communities and not widely available in typical American markets. Finding qualified masonry heater builders outside established communities often requires importing specialists or hiring firms that specialize in this niche construction. Geographic accessibility to qualified builders varies substantially across different American regions. Third, the substantial floor space and structural requirements for masonry heaters affect home design and architecture. Typical heaters occupy 25 to 45 square feet of floor space plus appropriate clearances, representing substantial spatial commitment within home layouts. The 4,000 to 8,000 pound weight requires proper structural support in the floor or foundation below. These requirements integrate easily into new construction but can challenge retrofit installations in existing homes. Fourth, the operational learning curve for effective heater use takes time to develop across multiple heating seasons. Users must learn appropriate loading patterns, firing schedules, and operational adjustments to achieve optimal performance. Families expecting immediate peak performance from new installations may face disappointment during the initial learning period before they develop the operational expertise that maximizes benefits. Fifth, the fuel handling requirements for wood-burning heaters impose ongoing responsibilities that some households find burdensome. Procuring, seasoning, splitting, and stacking 2 to 4 cords of firewood annually requires substantial time investment across the year. Families prefer set-and-forget heating approaches may find wood handling requirements incompatible with their lifestyles, even when the resulting performance and economic benefits would be compelling. Despite these considerations, Amish masonry heaters offer performance characteristics that few alternative heating approaches can match. The combination of extreme efficiency, low operating costs, excellent comfort, and extraordinary durability produces long-term value unmatched by most alternatives. The comparative analysis against modern high-efficiency heating alternatives. reveals masonry heater advantages across essentially every meaningful metric. Modern high-efficiency gas furnaces achieve roughly 96% thermal efficiency and reasonable service lives of 20 to 25 years. Masonry heaters achieve 85 to 92% efficiency with service lives of 150 years or longer. Modern heat pumps achieve excellent efficiency but require substantial electrical consumption that depends on grid reliability. Masonry heaters operate completely independently of any external infrastructure. Modern pellet stoves offer convenient automated fuel handling, but require electrical power for fuel feed and combustion air controls. Masonry heaters operate purely mechanically with no electrical requirements. Across essentially every dimension of heating system performance, the masonry heater produces better outcomes than any alternative for families willing to accept the initial investment and operational commitment. The economic analysis across extended ownership periods shows dramatic masonry heater advantages despite higher initial costs. A typical 50-year analysis comparing masonry heater operation against conventional gas heating, with periodic equipment replacements, fuel consumption across the period, maintenance costs, and various related expenses shows masonry heater total cost of ownership 60 to 75% below conventional heating. Extending the analysis across 100 years or longer, which masonry heaters easily support, shows even more dramatic advantages as conventional systems require multiple complete equipment replacements, while masonry heaters continue operating with minimal intervention. The integration with broader homestead and farmstead operations often produces additional benefits for rural families. Farms with woodlots can provide essentially unlimited firewood for masonry heater operation, reducing fuel costs to essentially zero beyond the family's own labor in wood preparation. The integrated approach to rural property management, including woodland, agricultural, and residential components, produces resilient economic models that reduce dependence on external infrastructure. Many Amish communities have optimized these integrated approaches across generations, producing family economic structures that prove remarkably stable across varying external economic conditions. The broader revival of interest in masonry heater construction has produced growing support infrastructure for non-Amish applications. The Masonry Heater Association of North America provides certification programs, ongoing education, and networking opportunities for builders and homeowners. Various regional organizations support specific traditional heating approaches, including masonry heaters. Academic programs at some sustainable building schools include masonry heater construction in their curricula. These developments support growing accessibility of masonry heater approaches for families outside traditional Amish communities who might benefit from these proven heating methods. The environmental implications of broader masonry heater adoption would produce dramatic benefits compared to typical heating alternatives. The exceptional fuel efficiency reduces total wood consumption by 60 to 80% compared to conventional wood stoves while providing equivalent heating services. The extremely clean combustion produces minimal emissions compared to alternatives. The extraordinary durability eliminates the environmental impacts of frequent equipment replacement that characterizes most heating alternatives. The integrated heating plus cooking functions reduce additional energy consumption for cooking functions in households that fully utilize these capabilities. The comparison with Russian, Finnish, and other traditional masonry heater traditions reveals both similarities and distinctive Amish variations. Russian masonry heaters emphasize specific cooking integration and extreme cold adaptation. Finnish masonry heaters focus on steam bath integration and specific fuel efficiency optimization. Amish heaters reflect Pennsylvania Dutch heritage, combined with subsequent practical refinement for American conditions and plain community values, emphasizing simplicity and durability over elaborate decoration. All these traditions share fundamental principles of concentrated combustion with extended thermal storage, but they've optimized for different specific conditions across their distinct regional and cultural contexts. Understanding these variations helps contemporary builders select design approaches most appropriate for specific applications and preferences. The resilience characteristics during winter emergencies provide substantial insurance value beyond routine operation. Masonry heaters operate completely independently of electrical systems, natural gas infrastructure, or other complex supply systems that can fail during winter storms. Families with masonry heaters maintain safe and comfortable indoor conditions through any foreseeable emergency scenario that might disable conventional heating systems. The resilience benefit grows increasingly valuable as climate patterns produce more frequent severe weather events that challenge conventional infrastructure. The insurance and code compliance considerations have evolved favorably for masonry heater installations in recent decades. Most American insurance companies now recognize properly installed masonry heaters as equivalent or superior to conventional heating equipment for safety purposes, providing standard homeowner insurance coverage without special considerations. Building codes have increasingly included specific provisions for masonry heaters, clarifying approval pathways that were previously ambiguous. Some jurisdictions now specifically exempt EPA-qualifying masonry heaters from wood-burning restrictions that apply to less efficient alternatives. These favorable regulatory developments support easier project completion than was possible in earlier decades. The cultural and aesthetic dimensions of masonry heater installation deserve recognition beyond pure functional analysis. The substantial physical presence of these heaters creates focal features in their homes, often developing into beloved elements that families genuinely treasure. The connection to traditional craftsmanship and multi-generational building knowledge provides meaningful cultural resonance. The daily ritual of heater operation during winter creates rhythms that connect family life to ancient patterns of heating that have sustained human civilization for centuries. These qualitative dimensions produce value beyond what simple economic analysis can capture. Consider what installing a traditional masonry heater means for a family's heating approach across multiple generations. The initial construction investment produces a heating appliance that will reliably serve the family across the next several human lifetimes. The operating costs remain extraordinarily low regardless of what happens to conventional energy prices across the coming decades. The comfort characteristics substantially exceed what conventional heating provides. The daily operational rhythms create seasonal patterns that many users find deeply satisfying. The environmental impact of heating decreases dramatically compared to conventional alternatives. The resilience against various emergencies provides real protection against increasingly frequent weather disruptions. The opportunity remains available for families willing to invest the initial resources and accept the operational commitment required for successful masonry heater ownership. The Amish communities have maintained this tradition across 150 years of continuous practice with accumulated expertise that delivers reliable results for families who adopt these approaches. Whether any particular family pursues masonry heater installation depends on individual circumstances, priorities, and willingness to adopt approaches quite different from mainstream American heating practices. The alternative exists. The evidence consistently supports the performance. The traditions endure. The opportunity waits for American families interested in proven solutions that offer fundamentally better heating characteristics than typical contemporary alternatives provide. The masonry heater represents accumulated wisdom about how to heat homes efficiently, comfortably, and durably using technology that humans have been refining since the earliest urban civilizations. That wisdom still works, still produces results that modern engineering struggles to match, and remains available to any family willing to learn from communities that have never stopped practicing this effective approach.